sort of going off of that, Dr. Ball, like other viruses, we've seen the coronavirus mutating and changing over the last 20 months. Now we have this Omicron variant. Why, in general, do viruses evolve, and what are the trade-offs that occur when viruses do change?
This is a really good question, Ian, and I think that there's a number of things that we can consider. So there's really four things that I guess to me are really important to consider. One is, if you look at what the life cycle of the virus is, it needs to be able to do three primary things. First, it needs to be able to enter and evade the primary defense mechanisms, the skin, the mucous membranes of the host, and attach to a receptor so that it can get into the cell and it can replicate itself. And then when it leaves the cell, it needs to be able to both evade our immune system and effectively get out into the environment. And then it also needs to be able to persist in the environment long enough to find a new host. Those are the three big challenges that viruses need to try to solve. So with the big environmental problems they need to try to solve in order to continue on and be successful. So as viruses, any virus is replicating, it's copying its genome, it's going to make mistakes. And I think what a lot of people don't realize is that the only viruses that we actually see and detect are the ones that those mistakes weren't too detrimental. So we never see any of the failures. We only see the successes. The success stories from the virus standpoint are those that are able to sufficiently answer those questions. Can I infect the cell? Can I replicate? Can I survive in the environment long enough to get to a new host? And so what we see over time is that each cell that gets infected creates tens to hundreds of thousands of copies of itself. And in every one of those replication events, there can be errors that are made. Some of them are detrimental and the virus doesn't survive. Some of them may confer an advantage and it helps them replicate faster. It helps them survive in the environment faster, or it helps them evade the immune system faster. And that's really the play that we have between the virus and the person that's infected, this constant interchange of the virus trying to shift and solve those problems that are being presented to it, and the body trying to adapt to be able to respond to those changes that the virus is making. I think with regard to Omicron, what we're seeing and what got scientists so worried was that the sheer number of changes that they observed in Omicron was unlike what we've seen with variants prior to that. And so the vast number of changes, predominantly in the area where the virus attaches to the host cell, is what's giving us problems both with the sort of lessening immune response or immune evasion of the Omicron variant. And also it seems to be making it more transmissible. So it's able to attach to cells faster, it's able to replicate faster, and it's able to disperse faster. And there's also some literature out there that would suggest that it may persist in the environment a little bit better too. So it appears that this virus, although lots and lots of information still to come on it as scientists study it, it may have found good ways to address all three of those big aspects that the virus needs to address in order to be more successful than, say, the Delta variant or previous variants.